up, my statisticians? I hope you're having a great day. Welcome to Mostly Math. I'm Ashley, and we mostly do math on this channel. And because it is very close to AP time, we're actually just going to do some big picture reviews. So today, we're going to talk about how to choose what inference procedure to use. Is it a hypothesis test? Is it a confidence interval? Are we using Z? Are we using T? Are we using proportions? Are we using means? Are we doing difference of means? Are we doing chi-squared? Are we doing chi-squared goodness of fit? Or, oh my God, pooled data? Oh my God, there's so many different things. How do you choose which one, right? So this video is not going to cover what each test does, all right, and how to perform it, and which what formulas to use. Okay, if you want a review on the comparison between the different tests, check out that video. This is a review video, so this is assuming that you already know the difference between all of these things. If you just look at the list of inference procedures that are options for AP Stats, I mean, there are more out there, but this is like what is covered in AP Stats, and kind of like beginning stats in college. There's a lot of them, right? You just take a look at that list there, you know? I mean, it's crazy. There's so many things that you would have to choose from. And if you look at this list, it's like super daunting. But I have a cheat sheet. I mean, not a cheat sheet. I have a way to kind of cheat the chaos. So when I'm deciding on an inference procedure, I first ask myself, what kind of data do I have? Is the data categorical or is it quantitative? Is it stuff and things and yeses and nos? Or is it, no, oh my goodness, it's windy out there. Or is it quantitative or numbers, numerical data? All right, as soon as you have that decision made, you've eliminated half of the tests. Okay, so that's question one. Question two is, what question are we trying to answer? Okay. And in this case, you want to look at, there's three different things you want to be thinking about. So one, are you looking for, is what you're looking at a hypothesis test type of a question where you basically just get a yes or no answer, or mostly a no or a not sufficient information answer, right? If you do a hypothesis test and you start with, mu equals 0 and you're testing to see if mu is not equal to 0, at the end of that all, you either get, yep, mu is not 0, or no, we don't know anything. Okay, so it depends. If that's your question, then, hypothesis test is great. Confidence interval gives you some information on the range of values. So if you're trying to kind of get like, does the data lean one direction or another, a confidence interval is typically really nice. And then the third question is, are you trying to establish a relationship? And if you're trying to establish a relationship, that's when we get into kind of those funky tests, the test for the slope of a least squares regression line, or the chi-squared tests. So if it's asking about a relationship, that's going to be your next question. And then last but not least, if we're dealing with hypothesis tests or confidence intervals, we want to know, is it one sample or is it two samples? Are you comparing one sample to a claim? Or are you trying to find information about a single sample? Or are you trying to compare two samples together? And there is a special case. There's actually a couple special cases, but the two special cases that I think are important to refresh yourself on, because the AP Stats, they love to ask these questions. So is the difference a mean of the differences. So this would be paired data where you're like lining up the data and you're finding the difference and then finding the mean of the differences. If you're not sure about that, I've got another video that I just did. It's like 5 minutes. You can go watch that. Right up there. And then, God, where was I? Yes, difference. Okay, so that is a special case where you have two sets of data. You would think that you're doing two sample, but because you're finding the difference between the two of them, you're actually only doing a single test. You're only dealing with a single sample, which is the difference between the two samples. And then the other special case is with pooled data. This only happens with proportions, and it's only if you're doing a hypothesis test where you assume that P1 is equal to P2, and you do all of the calculations. You're still doing two samples, but you do all of the calculations assuming that P1 is equal to P2. And so you can actually pool the data to combine and get a larger sample size, basically. So those are your special cases. But other than that, those three questions, is it categorical or quantitative? Are you looking at a hypothesis test, a confidence interval, or a relationship? And is it one or two samples? If you can get those three questions answered, you should be good to go. All right. So that's the general overview. And if you're good with that and ready to move on, great. Love you. Have a great day. If you want to see a couple examples, I have some lovely little examples over here. And we're just going to kind of talk about how to make the decision of which test to use for these guys. So let's just jump right in. Number 1, which brand of AA batteries lasts longer, Duracell or Energizer? You should pause the video before we do the examples. Pause the video, try these problems first, okay? That's the best way to learn, is to try it first, see where you messed up. Okay, don't just like watch me talk and go through it. All right, pause it, do your own thing. Okay, now come back. All right, question 1. Which brand of AA batteries last longer, Duracell or Energizer? All right, our question 1, is it quantitative or qualitative data? Well, it's asking about how long a battery lasts. So that's going to be measured in probably minutes or hours or days. So that's definitely quantitative numbers. So question 1, quantitative for sure. Question 2, are we trying to establish a relationship between these two things? No, definitely not. It's asking which one lasts longer, but it's not asking like, is there a relationship between Duracell and Energizer? That's not a thing. You can't, that's like a weird question to ask. So that brings us to, is it a hypothesis test or are we going to do a confidence interval? And in this case, it's asking which lasts longer, right? And if you think about doing a hypothesis test in this situation, you're going to have, brings us to our third question, is it 2 sample or 1 sample? We are going to have Duracell batteries, and then we're also going to have Energizer batteries, and then we're going to be comparing the two. So probably a 2 sample test. So we just need to decide, is it a hypothesis test or is it a confidence interval? Now, a hypothesis test, if you were to set up your null hypothesis and alternative hypothesis, you would have your null is that they last the same amount of time, so mu1 equals mu2. And then your alternative hypothesis would be that they're either not equal or that one is greater than the other. But if you try to prove that one is greater than the other, and then you kind of get down to the bottom, and then you can only conclude what you tested. So if you test the wrong thing, then you kind of like put yourself in a bind. And if you just prove that they're not equal, that doesn't tell you which one lasts longer. So in this case, it's actually best to do a confidence interval, because what you can do is find this, if you're testing Duracell minus Energizer, and how long they last, right? If the difference between the two of them is positive, if you do Duracell minus Energizer, D minus E, if it's positive, that means Duracell tends to last longer. If it's negative, then Energizer tends to last longer. It usually helps to think about like where you want to go, like where do you want to end up, okay? All right, so confidence interval, 2-sample confidence interval for mu1 minus mu2. All right, the reason that we ask the quantitative and categorical question is because if it's categorical, you're only dealing with proportions. If it's quantitative, you're only dealing with means, except if you're in that relationship, that weird relationship thing, which is chi-squared and the regression line, but we're going to ignore those for a second. Qualitative, you can only deal with proportions. Quantitative, you're dealing with means. So that helps you kind of dial it all in. So number 1, we have 2-sample T interval for mu1 minus mu2. All right, number 2. According to a recent survey, a typical senior has 250 contacts in their phone. Is this true at your school? All right. Quantitative or qualitative? Well, we're counting contacts. So quantitative, which means we're doing means. And it's asking, there's like a claim, and then we want to test whether or not your school is in alignment with the test or with the claim, or is it different than the claim? All right. There's nothing leaning one direction or the other. They're not asking, does your school tend to have more, like, do the students at your school tend to have more contacts in their phone? That's not what they're asking. They're just asking, is it different or the same? So this is going to be quantitative data. We've got, we're just at this point deciding between a hypothesis test and a confidence interval. And just because we're asking, is it this thing or is it not this thing, it's pretty straightforward to do a 1-sample t-test for the mean. Because your result, if you reject the null hypothesis, then you say, yeah, we have enough evidence to say that it is different at our school, or you don't have enough evidence to say that it's different, and so you kind of have to go with that. That's all it's really asking. So that's number 2. Number 3, what % of your students at your school are on Tick-tock? All right, so this, if you think about like the study that you'd have to do, you'd probably send out a survey and you'd ask people, are you on Tick-tock or not? Right? You do a sample, do a little random sample, ask people, are you on Tick-tock or not? The data that you're collecting is either a yes or a no. Okay, so is that quantitative or qualitative? That's our first question. It is definitely qualitative. You cannot measure yes or no except with proportions or percentages. So this is qualitative data. And we want to know, the next question is, are we doing a hypothesis test? Are we doing a confidence interval? Or are we doing like a relationship test? And it's not asking anything about a relationship. We just want to find an approximate estimate of how many people at your school are on Tick-tock, or what % of the people at school are on Tick-tock. To answer this question, you have no claim to compare to, so a hypothesis test doesn't actually make sense in this case. And we're doing qualitative data. The other option, other than a confidence interval, would be the chi-squared test. And in this case, we're not we're not comparing a relationship. There's no relationship to study. So we're just asking a simple question. And the best way to deal with this one is with a confidence interval, because you actually get a range, because if you do a confidence interval, you can say, we're 95% confident that the true proportion of people who are on TikTok at the school is between 30 and 60%, or whatever it is, right? So that was number 3. Number 4. Is there a relationship between how fast someone can run and how long they can survive the zombie apocalypse? All right, back to question number 1. Is it quantitative or qualitative? Well, what are we measuring? We are measuring how fast someone can run, which is probably miles per hour, meters per second, something like that. And then how long they survive the zombie apocalypse, which is probably measured in days, months, years, or seconds if they're not very fast. Okay? So we've got 2 types of data. They're both quantitative. So in your head, you should be thinking, all right, well, this is probably then either a 2 sample or maybe one of those relationship tests that we were talking about. So it does ask, is there a relationship? Shocker. Is there a relationship between these 2 variables? Well, since we're doing quantitative data, the relationship test is the t-test for the slope of a least squares regression line, because you would have how fast someone can run mapped to how long they survive the zombie apocalypse, right? Because you can have numbers on the x-axis and numbers on the y-axis, and then you can plot some data points and then make a line, and then you can test whether or not the slope of the line is not 0. Pretty simple, I think. Once you start asking those 3 questions, it's really not that hard, I think. That's in my head, but maybe it's still really confusing for you. And if that's the case, I'm really sorry that I'm not helping you. Okay, moving on. So for this one, we either have a t-interval for the slope or a t-test for the slope. You could probably do either one, honestly, because if you do the hypothesis test, you assume that the slope is 0, and then you get your answer, and then you say, oh, there is enough evidence to show that there is a relationship between these 2 things. Or you can do a confidence interval, and if the confidence interval is doesn't have 0, it's a tricky thing here. If you do a confidence interval, if the confidence interval doesn't contain 0, then you have enough evidence to show that there is a relationship. Nice little tip there. All right. Number 5. Is there a relationship between a student's political party and... that's the wind. It's crazy out there. Is there a relationship between a student's political party and what type of college they apply to? All right. Let's go back to the drawing board. Question 1, is it quantitative or qualitative? Well, we're looking at political party and type of college they apply to. So probably like liberal arts college or D1, D2, or we're talking about like law school or medical school. Who knows? But they're all categories. They're all qualitative data. So this is definitely qualitative data. Then what is the question asking? Is it asking for like a yes or no answer, like a hypothesis test? Are they looking for an interval of like a direction that this information is leaning? Or are they asking for a relationship? Is there a relationship between these 2 things? And in this case, yes, in fact, it is asking for a relationship between the political party and type of school they go to. So when we're dealing with qualitative data and relationships, we're talking chi-squared. So then you just have to decide, okay, is it goodness of fit? Is it homogeneity or association and independence? And this asks, is there a relationship between these two things? So homogeneity tests like, is it the same? That's not what they're asking. Goodness of fit is like, you know, you have a claim and then does your data fit the claim? This isn't that. So we are trying to find, is there a relationship between these two things? So we do chi-square test for association, because association means relationship. It's the same thing. Ding! You got it. Good job. Woohoo! All right. So that is number 5. Number 6. Who's more likely to own an iPod? Gen Zers, or millennials? Ooh. I mean, I think we already know the answer to this question, but it's fine. We'll just kind of keep going with it for the purpose of this video. Who's more likely to own an iPod? All right. Question number 1. Is it quantitative or qualitative? Well, you're going to be sending out a survey asking people, which generation are you in, and do you own an iPod? And so their answers are going to be yes or no, and either Gen Z or millennial, right? So your data is definitely qualitative. So we're talking proportions. And all right, so once you figure it out, it's categorical data, not quantitative. Then we go on to our next question. Is it going to be a standard hypothesis test? Are we going to do a confidence interval, or are we going to do one of the relationship tests? So you can immediately eliminate the relationship tests. That's not what it's asking. And then we want to know, okay, are we going to do a hypothesis test, or are we going to do a confidence interval? And in this case, it asks, who is more likely to own an iPod? Because it's asking for a direction without information about like which way it should lean. So if the question had said something like, it's been thought that millennials are more likely to have an iPod than Gen Zers, then you could do a hypothesis test with millennials having a proportion greater than the Gen Z. But that's not what the question is asking. It's asking, we don't know, and we want to know who is more likely to own one. So the confidence interval actually is the best option here, because when you do a confidence interval, again, you're going to do your Gen Zs minus your millennials. If you end up with a confidence interval that's all positive, then you know the Gen Zs tend to have more iPods, and if it comes out negative, all negative, then you know that the millennials tend to have more. Right? It just depends on which one you subtract from which. But that leads us to our third question, which I've already kind of answered. Is it 1 or 2 samples? And obviously this is going to be 2 samples, because you're going to have to ask both Gen Z and millennials, and then compare the 2 proportions to each other. So this is a 2 sample Z interval for P1 minus P2 is how you'd calculate that one, how you'd answer that question. All right, 7. How long do 16 to 18-year-olds spend doom scrolling each day? All right, this is another survey we send out, and we ask, hey, how long do you spend doom scrolling each day? And how much does that affect your heart? Because it hurts my heart really bad. I hate it so much. I'm definitely a millennial. I'm sorry if I'm not cool. No, I got my side part. I got my skinny jeans. But I can do math. So I hope you can too after these videos. All right. Anywho, moving on. All right, so how long do they spend doom scrolling each day? Question 1, is it quantitative or qualitative? Well, we're looking at time. So we're measuring in minutes, hours, whatever. So definitely quantitative. Is it a relationship question? Nope, not at all. And so now we just have to decide, is it 1 or 2 sample? And are we doing a confidence interval or a hypothesis test? So there's nothing, we're not comparing two groups, so this is definitely one sample. And the question asks, how long do they spend? You can't get that information with a hypothesis test. All you can answer is the question, do 16 to 18-year-olds doom scroll? Yes or no? So a hypothesis test is not appropriate in this situation. So confidence interval is the way to go. So for number 7, we have a 1 sample T interval for mu. All right, 8. Are the colors of Skittles equally distributed? What is that question asking? Well, are all of the Skittles colors, like, will you have the same proportion of reds as greens, as yellows, as blues? Or are they different? Do they, for whatever reason, make more reds than greens or make more blues than oranges? So we go back to question 1. Is it quantitative or qualitative? I know I sound like a broken record and you probably already stopped watching the video, but that's fine. Is it quantitative? That hopefully that means you understand it. Is it quantitative or qualitative? Well, we're talking about the colors of Skittles. So we're doing qualitative. And so this is a classic case for a chi-squared test. We just have to decide, is it goodness of fit, homogeneity, or association independence? So goodness of fit will always be, Skittles claims that they do, 20% red and 30% blue and 40% orange. And then you have to test, like you have, your bag of Skittles, and you have to test, is this actually accurate? Is their claim accurate or not for your bag of Skittles? So this is not that situation. We don't have that information. And it is not asking about an association between the colors. All it's asking is, are the colors evenly distributed? And that is a classic case of the chi-squared test for homogeneity, because homogeneous means the same. Yay, when math and words meet. Okay. All right, so number 8, chi-squared test for homogeneity. And then last but not least, we have number 9. Which brand of razor gives a closer shave? Researchers recruited 25 men to shave one side of their face with razor A, and then the other side of their face with razor B. Give you a second to think about it. Pause it if you got to think about it. This one's a little bit trickier. So this one is not terribly straightforward. The reason why is they haven't told you how you're measuring the closeness of the shave, right? So if they're measuring, for example, the length of the hair after a full shave, and you can like measure how long the little stubble is after they shave, then we're doing quantitative data. But if we're like having their partner come and like touch their face and be like, oh, this side is smoother than this side, or like a smoothness level. This is on a scale of 1 to 10. This side is okay, but a scale of 1 to 10 being, it's still categories. It's not really numeric. On a scale of totally smooth to a little rough to ow, then we're talking qualitative data. So depending on how you measure it is how you would answer this question. And then let's just, for shits and giggles, we'll do quantitative, measuring the length of the hair. And now we have one person shaving half of their face with one razor and shaving half of their face with another razor, okay? In this situation, you could do a two-sample probably confidence interval, because you want to find out which one shaves closer than the other. But because you're doing it on the same person, and you're probably randomly assigning which side of the face, you use each razor on. That's where the random assignment comes in. You can actually do a paired test on this one, because you can do length of the hair on this face minus on this side of the face with and subtract the length of the hair on the other side of the face. And so what you would actually be calculating and what you'd be testing is the difference between razor A and razor B. So even though you think you kind of have two samples, a better situation, because you can actually pair the data in this situation. If you can pair the data, you should, because it often makes a much better study. When you do the difference, you only have one set of data. You have the differences, and then you have a single mean of the differences. And so if you do it that way, you would actually end up doing a one sample T interval for mean, but the mean of the differences. So, because you have a paired test, paired data. You could do it with a two sample, but guaranteed on the AP Stats test, you'll lose points if you didn't do a matched pairs design on that one. Guaranteed. All right. That is it, folks. Man, that was a lot. I mean, you probably didn't watch all of it, but that's okay. Hopefully you got out of it what you needed to, and I hope it helps you pick the right test for problem number 6 on your AP Stats exam. Ooh, that's coming up. Good luck, friends. All right, bye.